my YouTube channel. I'm Nika Jununson, a third-year computer science student. In this video, we'll talk about discrete mathematics and discuss some of its topics. But first and foremost, I want you all to meet Tatiana Fernandez, also a third-year computer science student. Tatiana, what is the importance and benefits of discrete mathematics?
Discrete mathematics is a mathematical language of computer science. The abstraction is well-defined, convenient to conceptualize objects in computer science, such as cryptography, software development, programming languages, and so on. Also, it became handy when it comes to real-world application, when we are administering problem-solving situation. The benefits could be improving of reasoning, and it can enhance our problem-solving abilities.
Thank you, Tatiana. Very well said. How about benefits in pursuing computer science? As for me, I chose this career because I want to be a web developer or a game developer someday. And I believe that having a computing major will provide me a foundation of knowledge, problem solving, and logical thinking that will serve as a competitive advantage to me in my career in whatever field I choose. Oh wait! I want you all to meet Mikey Kirante, also a third-year computer science student. She will introduce the 3 topics that we are going to discuss today in this video. Mikey, are you there?
Yes, I'm here. Now let me introduce to you the topics that we are going to discuss: the trees, the Boolean, and the matrices.
Introduction of the topic. One of the topics that can be discussed within discrete mathematics is the trees. A tree is a connected undirected graph with no simple circuits. Importance of the topic. Trees are important in computer science due to its hierarchical ordering of data that can be used for storing and arranging, which are mainly applied in data structure. This tree is called M-array tree if every internal vertex has no more than m children. The tree is called full M-array tree if every internal vertex has exactly m children. Any M-array tree with m is equals to 2 is called binary tree. When an internal vertex has a child, then that internal vertex will be called the parent. Same goes with the internal vertex C and D, including the root, which is the A. If the parent has more than one child, the children will call each other as siblings. The ancestor of a vertex other than the root are the vertices in the path from the root to this vertex, excluding the vertex itself and including the root, which in this part, the root A, internal vertex B, C, and D are the ancestors. The descendants of a vertex are those vertices that was given vertex as an ancestor excluding the root. A vertex of a tree is called a leaf if it has no children. Vertices that have children are called internal vertices. Now to finish the introduction, a tree together with its root produces a directed graph is called a rooted tree. Moving on to our next topic, which is the tree traversal. In tree traversal, we have what we call the pre-order traversal, in-order traversal, and the post-order traversal. To be guided, I put letters with to understand the pattern of the given traversal. N as the root, letter L as the left node, and R as the right node, following the patterns. The pre-order traversal begins by visiting the R. It continues by traversing T1 in pre-order, and T2 in pre-order. The next one, in the in-order traversal, begins by traversing T1 in order, then visiting the R. It ends by traversing T2 in order. And for the last one, the post-order traversal, begins by traversing T1 in post-order, then T2 in post-order, and it ends by visiting the R. This is an example of pre-order traversal. Begins by visiting the root. It continues by traversing the left node, then follow the right node. Just follow the pattern until you reach the last node. For the pre-order traversal, this is the answer. In order traversal, begins by traversing the left node, then visiting the root, it continues by traversing the right node. Just follow the pattern until you reach the last node. For the in-order traversal, this is the answer. In post-order traversal, begins by traversing the left node, it continues by traversing the right node, and ends by visiting the root. Just follow the pattern until you reach the last node. For post-order traversal, this is the answer. So our next topic is about infix, prefix, and the postfix notation. To make such notation ambiguous, it is necessary to include parentheses in the in-order traversal whenever we encounter an operation. The fully parenthesized expression obtained in this way is said to be in infix form. We obtain the prefix form of an expression when we traverse its rooted tree in pre-order. We obtain the postfix form of an expression by traversing its binary tree in post-order. Now for the example, what is the ordered rooted tree that represents this expression? The answer is the infix form. Using the in-order traversal, it begins by traversing x in order, then the plus operator in order, then the y in order. It continues to a power in order, traversing 2 in order, then the plus operator in order, continues to x in order, to minus operator in order, and so on until it is traversed into in order. For the prefix, we begin by traversing x in pre-order, the plus operator in pre-order. It continues to a power in pre-order, the plus operator in pre-order, then y in pre-order, then traversing 2 in pre-order, the division operator in pre-order, to minus operator in pre-order, to x in pre-order, continues to 4 in pre-order, and ends by traversing 3 in pre-order. For the postfix, we begin by traversing x in post-order, y in post-order, then plus operator in post-order, then 2 in post-order, continues to a power in post-order, then traversing x in post-order, then traversing 4 in post-order, then the minus operator in post-order, traversing t in post-order, and so on until it ends by visiting the root.
So what is a Boolean? Boolean refers to the system of logical thoughts that is used to create a true or false statements. So now I will be discussing about the Boolean function. A Boolean function is described by a Boolean expression which consists of binary variables, the constants 0 and 1, and logical operation symbols. So Boolean is one of the fundamental points students will learn in computer science education as they explore the different ways that human uses programming syntax to interact with machines. Boolean is important to computer science because every character that is stored in a memory is in the forms of zeros and ones, which is also termed as the binary form. The reason is that it understands this language only. A Boolean function is a special kind of mathematical function. Binary function is formed with binary variable with the two binary operators or AND. Boolean function is represented with a capital F followed by a parenthesis composed of all variables separated by a comma. You can represent any Boolean expression in the form of a truth table. So let's have an example of the binary operator or first. The technique here is just like you're adding numbers but the answer is either 1 or 0. For example, 1 plus 1 is equals to 1. 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. 0 plus 0 is equals to 0. So for the binary operator AND, it's simple. We're just like multiplying 1 and 0. For example, 1 times 1 is equals to 1. 1 times 0 is equals to 0. 0 times 1 is equals to 0. 0 times 0 is equals to 0. For the complement or the unary operator NOT, you have to put the opposite of the input value. For example, if x is equals to 1, then the complement of x is 0 and vice versa. So let's have an example for two variables. Show a truth table for the following function xy is equals to x plus y. Boolean function represented by capital letter F. xy is the variable and the Boolean expression is x plus y. So let's create a truth table. We have two variables, so 2 squared by the number of variables is equals to 4 combinations of zeros and ones for a single Boolean expression. Since the binary operator is OR, let's add. 1 plus 1 is equals to 1. 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. 0 plus 0 is equals to 0. Let's have another example. F with a variable of x, y, z is equals to x plus y and z complement. Since we have 3 variables, so we have 2 squared by the 3 variables is equals to 8 combinations of zeros and ones for a single Boolean expression. Now, let's get the NOT or the complement of z. So the complement of 1 is 0. 0 is 1. 1 is equals to 0, 0, 1. Now, let's solve for the AND operator, which is y and not z. So 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 0 times 1 is 0. Then now, we solve x plus y and complement of z. So 1 plus 0 is 1, 1 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0 is 0. Now we get the function of f with a variable of x, y, z is equals to x plus y and complement of z. Easy, right? So now, let's move to the sum of products. Sum of product comes from the fact that the two or more products are summed together to create the final and/or output. We can display any sum of product in the form of a truth table. So let's have an example. Find the sum of products for the function f with a variable of x, y, z is equals to x plus y and complement of z. Let's create a truth table first. We have 3 variables, so let's make 8 combinations of zeros and ones. Let's get the OR operation x plus y. So, 1 plus 1 is equals to 1. 1 plus 1 is equals to 1. 1 plus 0 is equals to 1. 1 plus 0 is equals to 1. 0 plus 1 is equals to 1. 0 plus 1 is equals to 1. 0 plus 0 is equals to 0. 0 plus 0 is equals to 0. Then, let's get the complement of z. So the complement of 1 is 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1. Then we combine x plus y and z complement. So, 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 0 times 0 is 0, 0 times 1 is 0. Now, let's get the sum of products. To find the sum of products, we need to get all one output. So one here is x and y and z complement plus another one x and y complement and z complement plus x complement and y and z complement. So this is the sum of product for the function xyz is equals to x plus y and z complement. I hope you understand the Boolean function. So now let's move on to another topic, which is the logic gates. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. There are three basic types of logic gates: AND gate, OR gate, NOT gate, or the inverter gate. First is the AND gate. It has two input and one output. Then the OR gate. Same as the AND gate, it has two input and one output. NOT gate or the inverter. It has one input and one output. We can also create a combination of gates which consist of three basic gates: AND, OR, NOT. Let's get the OR gate first. Then the complement of Z, then we combine it using the AND gate. And that's the output for x plus y and z complement. Let's have another example for you to understand it even better. Let's create a circuit that will produce this output. First, let's create the input for x and y. And then we get the complement of x. And then the input of x complement and y. And then we combine it using the OR gate. There you go! We have created the output for x and y plus x complement and y. Well, that's all for our Boolean topic. Very easy, right? Do you think you can do it on your own now? Thank you for listening, guys!
Among the most common tools in computer science are rectangular grids of numbers known as matrices. It is a set of numbers laid out in rows and columns.
Matrices are so common in computer science. One of the areas in computer science in which matrix is particularly useful is the graphics, for its ability to convert geometric data into different coordinate systems.
A matrix is a rectangular array of numbers. A matrix with m for rows and n for columns is called an m by n matrix. Here is an example of 3 by 2 matrix. It has 3 rows and 2 columns. Addition in matrix arithmetic, just add a and b with same places. 1 plus 3 is equal to 4. 0 plus 4 is equal to 4. Negative 1 plus negative 1 is equal to negative 2. 2 plus 1 is equal to 3. 2 plus negative 3 is equal to negative 1. Negative 3 plus 0 is equal to negative 3. 2 plus negative 1 is equal to 1. 4 plus 1 is equal to 5. And 0 plus 2 is equal to 2. That's all. Very simple, right? Multiplication in matrix arithmetic. This is not the same process with addition. So in here, you'll multiply the rows of A to the columns of B. Rows of A to the columns of B. Rows of A to the columns of B, and so on. So let's start. 1 times 2 is equal to 2. 0 times 1 is equal to 0. 4 times 3 is equal to 12. And you'll add this 3, and the answer is 14. And then you will write the 14 in here. Next, 1 times 4 is equal to 4. 0 times 1 is equal to 0. 4 times 0 is equal to 0. And 4 plus 0 and 0 is equal to 4. And you'll write in here the 4. Next, 2 times 2 is equal to 4. 1 times 1 is equal to 1. 1 times 3 is equal to 3, and 4 plus 1 and 3 is equal to 8. You'll write this to 8. Next, 2 times 4 is equal to 8. 1 times 1 is equal to 1. 1 times 0 is equal to 0. And 8 plus 1 and 0 is equal to 9. Okay, 9. 3 times 2 is equal to 6. 1 times 1 is equal to 1. 0 times 3 is equal to 0. 6 plus 1 plus 0 is equal to 7. Okay, 7. 3 times 4 is equal to 12. 1 times 1 is equal to 1. 0 times 0 is equal to 0. 12 plus 1 plus 0 is equal to 13. Next, 0 times 2 is equal to 0. 2 times 1 is equal to 2. 2 times 3 is equal to 6. 0 plus 2 plus 6 is equal to 8. Okay, 8. Okay, last one. 0 times 4 is equal to 0. 2 times 1 is equal to 2. And 2 times 0 is equal to 0. And 0 plus 2 plus 0 is equal to 2. Okay? And this is the final answer. So, as you can see, the rows of A is the number of rows of A times B, and the columns of B is the number of rows of A times B. Let us now proceed to the transposes and power of matrices. So in here, the rows will be the columns. The row 1, 2, 3 will be the column 1, 2, and 3. The row 4, 5, 6 will now be the column 4, 5, and 6. A square matrix consists of same number of rows and columns. It will be called symmetrical if you transpose it, and the result is still the same. So in here, the row 110 will now be the column 110. The row 101 will now be the column 101. And the row 010 will now be the column 010. And the result is still the same. Let us now proceed to the join and meet of 0-1 matrices. Here's the formula for the join. Here's the formula for the meet. The technique in here, the join is like a binary addition, while the meet is like a binary multiplication. As you can remember, or for those who don't know, binary addition is 1 plus 1 is equal to 1. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. And 0 plus 0 is equal to 0. While in binary multiplication, 1 times 1 is equal to 1. 1 times 0 is equal to 0. 0 times 1 is equal to 0. And 0 times 0 is equal to 0. Here is an example for the join. Let us first derive the formula. 1 join 0. 0 join 1. 1 joins 0. 0 join 1. 1 join 1. and 0 join 0. And now, let's start the addition. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. 1 plus 1 is equal to 1. And 0 plus 0 is equal to 0. And this is the final answer. Next is the meet. Again, let us first derive the formula. 1 meet 0. 0 meet 1. 1 meet 0. 0 meet 1. 1 meet 1. And 0 meet 0. Now, let's start the binary multiplication. 1 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 1 is equal to 1. And 0 times 0 is equal to 0. And this is the final answer. Boolean product. Same process like the multiplication in matrix arithmetic. Rows by columns, and so on. So first, they will meet and then they will join. 1 meet 1 and it will join 0 meet 0. 1 meet 1 and it will join 0 meet 1. Next, 1 meet 0 and it will join 0 meet 1. Next, 0 meet 1 and it will join 1 meet 0. Next, 0 meet 1 and it will join 1 meet 1. Next, 0 meet 0 and it will join 1 meet 1. Last row, 1 meet 1 and it will join 0 meet 0. Next, 1 meet 1 and it will join 0 meet 1. 1 meet 0 and it will join 0 meet 1. To check if it is correct, here's the technique. So it's 1 0 1 and 0 1 0. 1 0 1 0 1 0. 1 0 1 0 1 0. 1 0 1 0 1 0. 1 and 0, 1 and 0, 0. 1 and 1, 1 and 1, 1. 0 and 1, 0 and 1. Okay, it is correct. Let us now simplify this. 1 times 1 is equal to 1. It will join 0 times 0 is equal to 0. 1 times 1 is equal to 1. And it will join 0 times 1 is equal to 0. 1 times 0 is equal to 0. It will join 0 times 1 is equal to 0. 0 times 1 is equal to 0. It will join 1 times 0 is equal to 0. 0 times 1 is equal to 0. It will join 1 times 1 is equal to 1. 0 times 0 is equal to 0 and it will join 1 times 1 is equal to 1. 1 times 1 is equal to 1 and it will join 0 times 0 is equal to 0. 1 times 1 is equal to 1 and it will join 0 times 1 is equal to 0. 1 times 0 is equal to 0 and 0 times 1 is equal to 0. Addition for the join, 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. And 0 plus 0 is equal to 0. And this is the final answer. Our last topic is the Boolean power. It has something to do with the Boolean product. The only difference is you will only have one given and you'll just need to duplicate it with the number of power given. So in here, we're looking for the second power of a, so the formula will be a times a. So I will write here the duplicate of a so we won't get confused. As you can see, This is the original A and the duplicate of A. So let's start the meet and join. 0 meet 0, and it will join 1 meet 1. 0 meet 1, and it will join 1 meet 1. 1 meet 0, and it will join 1 meet 1. Next, 1 meet 1, and it will join 1 meet 1. Let's check if it is correct. So 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0 and 1, 0 and 1, 1 and 1, 1 and 1. Now, let's start the multiplication. 0 times 0 is equal to 0, and now it will join 1 times 1 is equal to 1. 0 times 1 is equal to 0, and it will join 1 times 1 is equal to 1. 1 times 0 is equal to 0, and it will join 1 times 1 is equal to 1. 1 times 1 is equal to 1, and it will join 1 times 1 is equal to 1. Now, the binary addition. 0 plus 1 is equal to 1, 0 plus 1 is equal to 1, 0 plus 1 is equal to 1, and 1 plus 1 is equal to 1. And this is the final answer of the second power of A. But what if we're looking for the third power of A? Have you ever wondered that? That's very simple. First, you just need to find the second power of A. After that, you'll be able to find the third power of A. So the formula for that will be, in finding the third power of A, first, you need to find the second power of A, and then multiply it with the original A. So in here, this is the second power of A, and I will multiply it with the original A. That's all. Thank you.
Thank you for watching. I hope you learned something from us.
So if you have any questions, feel free to comment down below and we will surely get back to you.
Good luck on your career! I hope this video inspired you to take computer science. Thank you for watching!